Alright, so let's look at another set of questions on the AP and the GP, just for practice. So find the 10th term of the AP, whose first term is 55 and the 7th term is 155. Find the 7th term of a GP. Here we are told the first term is 9 and then the 5th term is 144. And we are also asked to evaluate the sum of the first 25 terms of the progression. Determine the number of terms where they've given you the first term, the common ratio, and the sum. So how many terms were added in that series for them to get 62? That's what the question is asking. Okay, so we'll start question 1, or question A, that is. Find the 10th term of the arithmetic sequence whose third term. So the third term, we can either denote it as A subscript 3 is 55, and then we are told the 7th term is 115. We need to find the 10th term. So this is an AP, or arithmetic progression, or arithmetic sequence as called in this case. One thing that you basically need to understand is the fact that the formula for the arithmetic sequence of the AP is what? What's the formula for finding the nth term? So an is equal to the first term plus n minus 1 and then multiply by the common difference, which is a d. Okay, so we'll use that formula to help us find the first term and the common difference, which we need for us to help us find the 10th term. Okay, so if I look at the third term, let's come up with a formula based on that. So if we substitute here, a3 is going to be the first term we don't know, and then n, that's the third term, so it's going to be 3 minus 1, which is going to just be 2 multiplied by d. On the other hand, for the 7th term, it's going to be the first term as well, plus, if you substitute there 7 minus 1, it's going to give us a 6d. So we know the third term is 55. We know the 7th term is 115. Okay, so these are simultaneous equations which we can actually solve. Okay, I can take this one and write it down there. So I have 55, and then we have a1 plus 2d. So use any method that you're comfortable with to solve these two simultaneous equations so that you find the first term and the common difference. So if we go by elimination, if we subtract, we know the first term will actually subtract, right? So now we get to a point where we're subtracting 115. Okay, so 115 subtract a 55. Okay, so you get a 60 there. This part will be eliminated. You remain with on the other hand 6 minus 2d, that's going to be 4d. So divide by 4, you find that your d becomes what? Your d becomes 15 there. After you find the d, you can get any equation. I can get the one with the smaller numbers. 55 is equal to a1 plus 2d, so that we find the other missing number or other variable. a1, our common difference is 15, so we end up with 55 minus 30 is equal to a1. Now 55 minus 30 is what? That's a 25. So we've determined all that we need for us to thrive in this question. Now we are very much sure we know what we need to do for us to be able to find the 10th term. Okay, how do we find the 10th term now that we have what we needed? So a10 is going to be dependent on the first term plus n minus 1. So this formula has actually become easily recalled, especially when you practice more questions. Okay, so the first term is 25. The common difference, or n minus 1, that's the 10th term, so 10 minus 1 multiplied by the common difference 15, 25 plus 9 multiplied by 15, right? So we have 25. 9 times 15 is 155. 155 plus 25, 5 plus 5 is 10, 150 plus 10, that's 160. So the 10th term of this AP is 160. Okay. Now if we go to B, we are given the 7th term of, we are asked to find the 7th term. Okay. So it's a similar question except it's dealing with a geometric sequence. So here we are told the first term is 9, and then the fifth term is 144. So we are supposed to find the sum. Now, what's the formula for the sum of a GP? What's the formula for the sum of a GP? Okay. So the formulas are determined by the ratio, or the common ratio, whether it's greater than 1 or less than 1. So for where it's greater, where r is greater than 1, you can have a formula like Sn is equal to first term and then r to the power n minus 1 divided by r minus 1. So you see that what we need here is we need the common ratio and the first term. So we don't have them. We have a first term, we don't have the common ratio. So let's try to make most of this guy. That's a fifth term. The formula for the nth term of a geometric sequence is a subscript n is equal to a r n minus 1. Okay, so we are told the fifth term is 144. This a1 is 9. Our r is what? Is what we're trying to find. And then our n, this is the fifth term, so 5 minus 4. Okay, so we end up with 144. Can divide by 9 the r to the power 4. 144 divided by 9 is what? So that gives us 16. Find the fourth root on both sides. Your r becomes 2. Okay, so we found what we actually needed to find. So our r is actually equal to 2. So how do we find now the 7th term that they require us to find? So the formula an is equal to ar n minus 1, right? So 7th term, first term is 9, r is 2. Now raise to the power n minus 1. What's n? 7. So 7 minus 1. Okay. So you end up with 9 multiplied by 2 to the power 6. Okay. Now what is 2 to the power 6? That's 64. So 9 times 64, which is just basically equivalent to 576. Okay. Are we done? No. So we're also asked to evaluate the sum of the first 25 terms of this progression. So don't forget our first term is 9. We found our common ratio to be a 2. Now the r of value here, which is the common ratio, is 2, which is greater than 1. So our formula for the sum is going to be a1 rn minus 1 divided by r minus 1. You can substitute sum of the first 25 terms. Our first term is 9. Our common ratio is 2. Now this will be the power 25 minus 1 over 25 minus 1. Okay. So what do we have? So on the bottom for the 25 minus 1. So s25 is equal to, any way that we can actually simplify this, we can actually just by simplifying the numbers, 2 to the power 25, which I'll leave to you to simplify. Okay, so actually, what have I done here? On the bottom it's r minus 1, so our r is actually 2 minus 1, not what I've put. So that will just remain with 9 to the power 25 minus 1. Okay, so I'll leave it to you. Simplify to the power 25. So if you're not allowed to use calculators, just end there. If calculators are allowed, you can punch to the power 25, subtract a 1, and then multiply by the 9. That will give you the sum of the first 25 terms of this GP. Now another question is focusing on determining the number of terms in the series, where we are taught the first term is 2, common ratio is 5, the sum of these any terms 62. Okay, so look at the value of our r there. The value of r is 5, which is greater than what? Which is greater than 1. So we use the same formula that we've previously used. Try to recall it. Okay, this is a GP. So A1 Rn minus 1 over R minus 1. The sum is 62. First term is 2. Common ratio is 5 raised to the power n minus a 1 divided by common ratio, which is 5 minus a 1. Okay, so I have 62 is equal to 2 5n minus 1 divided by 4. At that point we can do some divisions. 2, it's 1, 2, where it's 2 times 62, that's going to be 124. Okay, after I cross and multiply, there we just have a 1, so the brackets can be removed, and then we end up with 125 if the 1 goes the other side. Okay, so we add the 1 both sides. Okay, so we have a very basic indice. Yeah, so 125 is the same as 5 to the power 3, which is equal to 5n. Therefore our value of n is what? 3. Okay, so that's it for C. Alright, so let's undo a question on the arithmetic and the geometric progressions. Okay, so we've got two questions. The first one is on the AP, the other one is on the GP. So starting with the first one, the sum of the first two terms of the AP is 40. The sum of the first 4 terms of the same progression is 130. Determine the sum of the first 5 terms of the same AP. Okay, so what's an example of an AP or an arithmetic progression? So 1, 3, 5, 7. So we are saying this is where we have what we call a common difference. So we are just adding a 2 to the previous term to get the next term. That's what an AP is. So it's a common difference there. Okay, so we are taught the sum of the first 2 terms. So the sum of the first 2 terms is 40. The sum of the first 4 terms is 130. Determine the sum of the first 5 terms. So basically, whenever you want to do computations concerning the AP, it's important that you find the first term which we denote by A and the common difference which we denote by D. Okay, one other formula that you might want to know of is for determining the nth term, which is A plus, prefer starting with opening the brackets, and then there you've got n minus 1, and then multiplied by the common difference. Okay, so now in this case we're dealing with a sum. The sum of an AP is given as n over 2, open the brackets, 2a plus the same brackets we had n minus 1 multiplied by the common difference d. Okay, so the sum of the first 2 terms, what do you do? So where there's n, you put 2. So sum of the first 2 terms, so it's 40. Where there's n, we're going to put a 2. Okay, where else do we have n? There we've got n as well. So you end up with 40 is equal to, this is just going to be a 1, and then in the brackets you remain with 2a. 2 minus 1 is a 1, multiplied by the d is just a d. So that's what we have. 40 is equal to a plus d. Simple and straightforward. Now for the other part where we've got the sum of the first four terms. Sum of the first four terms. So we've got 130. Our formula is n over 2, so it's going to be 4 over 2. 2a, okay, n minus 1. Our n in this case is 4 minus 1, gives us a 3. Okay, apply by the d. So you end up with 130 is equal to 2. Open the brackets, 2a. That's going to be 3d. So you're seeing where we are adding to, right? You end up with two simultaneous equations. Okay, so that's going to be 4a. In fact, you can just make it, you can just do something easier there. Without multiplying by 2, you can just divide by 2 both sides. So 130, what happens if you divide the 130 by 2? That would be 65. So we've got 65 is equal to 2a plus 3d. The other one is 40 is equal to 2a plus d. You can solve using any simultaneous method that you know, either elimination. You can also use substitution. Okay, so I'll just use elimination. Looks easier and straightforward here. So just subtract 65 minus 40, that will be 25. 2a minus 2a is a 0. 3d minus d is going to be 2d. So therefore our d is going to be 25 and then divided by the 2, right, which would be 12.5. So found the common difference, and then we can now find the first term. Get any of the two formulas. I can get the one with 40, so 40 is equal to 2a, where there is d, we've got 12.5. So 40 minus 12.5, okay, so collecting the like terms, we're going to have 40 minus 12.5 is equal to 2a. 40 minus 12.5, 40 minus 12.5, 27.5 is equal to 2a. Divide by 2. So the answer I'm getting for the first term is 13.75. Okay. So now that we've got these, now your task is for you to use the formula for the sum that I gave you. I said n over 2, 2a plus n minus 1 multiplied by d. Okay. So the sum of the first 5 terms. So s is equal to 5, or n is 5. So got 5 over 2, and then your a is 13.75, and then plus n minus 1, that's going to be 4, and then d, because 5 minus 1 is a 4, so 4 times the d, it's 4d. So simplify that, you'll be able to get the sum of the first 5 terms. Okay, so just to confirm your solution, the solution I'm getting is 193.75. Okay, now that we're done with the question on the AP, let's look at the question on the GP. The sum of the first 2 terms of a GP is 40. The sum of the first 4 terms of the same geometric progression is 130. Find the 2 possible values of the sum of the first 5 terms of the geometric progression. Okay, so the GP, just like the AP, has got its own formulas. And what makes a GP? Consider 1, 3, 9, 27. This is a GP. Okay, this is what we call a common ratio. So I've been multiplying by a value of 3 there. And so if you try to divide this term, 3 divided by 1 is a 3. Again, divide 9 by 3 is 3. 27 by 9 divided by 9. So you find that this is what we call a common ratio. Okay, that's what makes a GP. Now we're taught the sum of the first 2 terms of a GP is 40. Okay, and then the similar manner, the sum of the first 4 terms is also 130. So the formula for finding the nth term for the GP, just in case you want to know, is a r n minus 1, where r is a common ratio, a, just like in the AP, is also the first term. Okay, and then what do we have? So the formula here, there are two formulas that we usually use. Okay, so a1 minus r to the power n, and then of course 1 minus r. So this occurs in cases where the r value is going to be less than a 1. Okay, when the value of r is expected to be less than a 1, basically that's what you expect. Okay, now there are cases where you've got a and then rn, like that. Okay, where the value of r is expected to be bigger. So how do we handle this question? So let's try to substitute in our formula for the sum. Sum of the first two terms we're told is 40. So 40, where there is a, we don't know the first term, or r we don't know, but all we know is this is sum of the first two terms. Okay, and then also on the other hand as well, the sum of the first four terms is 130, so equally to be a 1 minus r to the power 4 divided by 1 minus r. Okay, so we also need to solve these as simultaneous equations. Okay, so how do we proceed from here? How do we proceed? So we can get the ones with bigger values. So 130 is equal to a 1 minus r to the power 4, okay, and then over 1 minus r. So what do we do here? Since we want to solve them simultaneously, we want to see what values can satisfy both equations here. Okay, since we can see that the denominator is actually the denominator is actually the same for both of them. So if we were to do something like trying to divide both sides by the simple of a smaller equation, that is this one on the bottom. So 40 is equal to a 1 minus r to the power 2 over 1 minus r. So what do you expect there? So what's going to happen is, on the right, this dividing with what we have. So dividing, I usually say it's as good as multiplying by the reciprocal, which is going to be 1 minus r multiplied by divided by a 1 minus r squared, meaning that we just swap them. Then on the other hand, we just have division by 40. So what happens when you divide? So you get 3.25 on the left, this and that will divide, the a will equally divide, so you remain with 1 minus r to the power 4 and then 1 minus r squared. Okay, trying to simplify this, you can cross and multiply. So we've got 3.25 multiplied by 1 minus r squared is equal to 1 minus r to the power 4. Okay, what do you end up with after distributing? 3.25 minus 3.25 r squared is equal to 1 minus r to the power 4. Okay, correcting the like terms to be all on the left, the highest power going to have will be r to the power 4, followed by 3.25 r squared plus 3.25 minus the 1 equal to 0, which if we subtract will just give us 2.25. How do we simplify this? To simplify that, it's easy. Okay, so we can't solve this big equation directly, So let's come up with it. Let's generate a quadratic function. So let's say our x be equal to r squared. So while there is r to the power 4, we're going to have x squared minus 3.25. Where is the r squared? We are going to have x. Okay. So now I'll leave it up to you. Please make a step and solve that quadratic equation. Okay. Solve the quadratic equation. Pause the video and solve the quadratic equation. Okay, so the x values 3.835 or negative 0.585. Okay, so to find the value of r, which is our interest, r squared is equal to x. So r squared therefore is equal to 3.835. So that we find the square root. So plus or minus the root of 3.835. This one is not part of the solution set because we can't find the square root. Okay. So the square root of that, r is going to be plus or minus 1.96. So that's how we handle this question. Now we've just found the missing values. We've only found r so far. Okay. Our r is that. So let's go for a positive value, 1.96. Okay. If r is equal to that, how do we find our n? Because there are two possible cases. There's also negative 1.96. So there are two cases here. That's why the question says find the two possible values of the sum of the first 5 terms. So if you go back to the equations that we had, I'll get the simpler one. 40 is equal to 1 minus r squared over 1 minus r. Okay. So if I'm in your position, I can just go to a point where we had r squared, right? R squared was something like what? What did we have as r squared? 3.835. That was before determining the square root. And then substitute. So 40, our first term we don't know. Our r squared is 3.835. And then we are dividing by 1 minus r, right? So let me write that properly. 40 is equal to our first term, we don't know, and then 1 minus 3.835 divided by 1 minus r. Now r is 1.96 for this case. Okay, so 40 is equal to a. Now subtract 1 minus 3.835, okay, divided by 1 minus 1.96. So that's going to be negative 0.96. So get a positive value of 2.95. 40 divided by 2.95. So a possible value of the first value is 13.56 for this other case. Okay, so a is 13.56 where our r value was positive 1.96. So I want you to find the value of a for that case. Okay, so for this case these are the two values. So now to find the actual value of the sum of the first five terms, you go back to the formula, 1 minus r to the power n divided by 1 minus r. Okay, so I've said I'm doing one case for you, you can do the other case. So the sum of the first 5 terms, our first term is 13.56, and then 1 minus our ratio is 1.96 raised to the power in this case should be raised to the power 5 divided by 1 minus 1.96. So 1.96 raised to the power, raising it to the power 5, right? Okay, so I'm getting 28.9 after squaring that, and then if you subtract it from a 1, you get negative 27. Multiply by that, 13.56. I'll do that again. So after subtracting from 1, we have 13.56 multiplied by negative 27.925, and then on the bottom we're going to get negative 0.96. So that value multiplied by 13.56 divided by negative 0.96. So I'm getting something like 394.4. Okay, this is for this case. Now use this value to find the first term, and then also find the 5 terms for that possibility. Okay, so end here for this question. I hope you now get ideas on how to go about the formulas under the AP and the GP. If you want to learn this topic in full, use the link in the description below to have access to our site. Alright, so we're looking at another very common kind of a question under a GP, where they've given us to say we've got the first term to be x, and the other one is x plus 3, then the third term is 4x. The question is find the two possible values for the common ratio. For each value, find these first 3 terms. Okay, so now the common ratio, I gave you an example to say in a GP, if you are to have a 1 as the first term, if your common ratio is a 2, the implication is for you to find the other terms multiplied by the 2, which would be 2, 4, 8, 16. Now, the reason why we call it the common ratio is if you are to divide the term that is a 8 by the preceding one, you'll see, for example, 2 divided by 1 should be equal to 4 divided by 2, equally, which should be equal to 8 divided by the previous term, just like that. It's common. It's a common ratio. So using that very principle there, we can actually apply it. This is a second term. So a second term divided by the first term should be equal to the third term divided by the second term. Okay, this should be equal. From here we can come up with a quadratic equation. Of course, we can multiply this with that. So we end up with x plus 3 squared should be equal to 4x squared. From there we can come up with a quadratic equation. Expanding what is on the left, we can have x squared plus 6x plus 9 equal to 4x squared. Okay, we can try to collect the like terms. I prefer starting with a positive 4x squared, so you can have a 0 on the left. So 4x squared minus x squared minus 6x minus 9, so end up with 3x squared minus 6x minus a 9. That's what we have right there. Okay, this is our quadratic equation now. This is equal to 0, so we can solve it. So use the formula. Our formula is negative b, so negative 6 plus or minus the root of b squared. In this case, b squared is minus 6 minus 4ac. Our a is 3, our c is negative 9, divided by our 2a. Our a is 3. Yeah, simplify just that simple basic quadratic equation. So negative times that is going to be positive, plus or minus. This is going to be 36. 4 times 3 is 12. 12 times 9, that's 8. 9 plus 1, 10. 108. 108 plus 36. That's 144. over 6, which will be 6 plus or minus root of 144 is a 12, and then divided by 6. So the two possible values of r are, one is what? Not the possible values of r, possible values of x is 6 plus 12. 6 plus 12 is what? 18 over 6. The other one is 6 minus 12, which is minus 6 over 6. So the two values of our x are 3 and negative 1. Okay, so to find the first three terms, in fact, we've said find the two possible values of a common ratio. So first of all, we can try to substitute and find the first three terms. For this case, where our x is 3, just substitute. So we're going to end up with 3 and then 6 for the second part. 4 times 3 for the other part gives us a 12, right? Then for this guy, this side, negative 1, and then negative 1 plus 3, that's a 2, that's negative 4. So these are the three possible terms for each case. Now what are the common ratios? Common ratio here is going to be 6 over 3, which is of course 12 over 6. We're seeing here it's a 2. The other side, the common ratio is 2 over negative 1, which is also negative 4 divided by 2, which is equal to a negative 2. Negative 2 for the other case. Okay, and you can actually observe it. If you multiply the 3 by 2, you get 6. 6 times 2 is 12. Negative 1 times negative 2, positive 2, and then get negative 4 again. So that's it to this question.